So now let's look at analyzing an unknown sample of urine to find the calcium content using that standardized manganese. So here is the situation. We have calcium that was in a 5 milliliter urine sample, was precipitated with oxalate according to the procedure that we showed in the last video, and then redissolved. And then once it was redissolved, the oxalate was not precipitated, but was titrated with the standard permanganate. And I wrote the concentration here on the right, over here. Required 16.17 milliliters of the standard to reach the endpoint. And our original goal, of course, is to know what's the concentration of calcium in the urine. So let's go ahead and go through this. So we know that it took 16.17 milliliters of the standard permanganate to reach the endpoint. So that means let's use that as our starting point. That's the thing we measured. So 16.17 milliliters of standard. All right, so let's convert that to moles of our permanganate. So we know that we have our concentration over here. So we know that it's 8.7947 moles per times 10 to the minus 4 moles per liter. So our units don't match up here. We need to be able to convert to milliliters. So we know that for every 1 liter, there's 1,000 milliliters. So that'll get all of our concentration. So our liters will cancel, our milliliters will cancel. All right. And that will give us the moles of permanganate. So if we multiply that out, that gives us 1.422 times 10 to the minus 5 moles of permanganate. Okay, but then we need to take into account the stoichiometry, which again is in the previous video, that for every 5 moles of oxalate, we have 2 moles of permanganate that react with it. So let's continue our calculation here. So we can take this 1.4221 times 10 to the minus 5 moles of permanganate, and we know that 2 moles of permanganate, that should have the moles in there, will react with 5 moles of oxalate. Okay, and that will give us 0.035553 millimoles. Mixing up units here, of C2O4 2 minus. Okay, and we know that in our original oxalate solution, or original reaction that we did, where the calcium and the oxalate precipitate, we know that is a 1-to-1 ratio. So for every 1 mole of C2O4 that we got from our solution here, we know that reacted with 1 mole of calcium. So we got to keep track of what's happening with all the reactions here. A lot of analytical chemistry calculations are, in some sense, bookkeeping. Keeping track of how many moles react with how many moles, and making sure that we have stoichiometry correct. So that means that the number of moles of oxalate here is also the number of moles of calcium that was in the original solution, because we precipitated all of it out. So then our question that we had at the beginning was, what's the concentration of calcium in the urine sample? Now we know how many moles there are. We just need to divide it by the fact that it was a 5 milliliter sample. So we take 0.035553 millimoles divided by 5.00 milliliters. And one handy fact to note is that a millimole per milliliter is the same as a mole per liter. If we just take milli of both of them, it's still equivalent. So that's useful if we do things in millimoles and we divide by milliliters. That still gives us molarity. So we don't need to do any further unit conversions here. Okay, so we can do that, and that gives us a concentration of 0.00711. We only have 3 significant figures now because this number down here only had 3. We can carry 1 more digit here, molar. So this is the concentration of calcium in the urine sample.